Good
Welcome
morning.
again. Class of Good morning, beta. Welcome again in the class of COA. Yesterday we discussed two questions of subjective type. First one was about the architecture of 8085. Second one was about the pin diagram and their description. And now in the same unit we have two more questions of subjective type nature, that means a 12 marks question. So what the first question is, what is an addressing mode? Discuss them in the context of microprocessor 8085 with appropriate examples. So here we need to define the addressing mode first, then we need to discuss all the addressing modes, those we have studied in microprocessor 8085. Fine, and we are also going to put some example. And in the same way we can have second question, define an instruction and instruction format and explain any 10 instructions with example. Here the division of marks is like 1 marks for, always take care of the division of the marks also. Define an instruction, it takes 1, and instruction format, it takes 1, and rest of the 10 marks are for explaining the 10 instruction correctly. So today we are going to to study these two questions, answer of these two questions. So let me start. The first question, the answer of the first questions we will give. So we have the addressing modes. So addressing mode is, what is addressing mode? The addressing mode is a way of specifying the operand and the opcode. How we are actually making the instructions. So in the instruction, you all know this is the opcode and the operand. Operands are there, and how we define them? I mean, there is some particular rules to specify these operands into the instruction, and this way of specifying the data entities or the memory or the registers, we need to specify some methods, and those methods are actually given by the addressing mode. Fine, these are given by the addressing mode. And in 8085 we have 5 addressing mode: the immediate, the direct addressing mode, the register direct addressing mode, the register indirect addressing mode, and the implicit addressing mode. So let us discuss all the addressing modes in detail. So addressing mode, as I have already told, addressing mode specify the way of putting the operands in the instruction. Fine, I mean how to specify the address of the source and how to specify the address of the destination. So by that way, we have first addressing mode is immediate addressing mode. In this mode, operand whether 8-bit or 16-bit is specified in the instruction itself. And here we can take one of the example. In this instruction 05H, the instruction is MVI A, 05H, where the meaning of this instruction is move immediate the data 05H into accumulator. Here the 05H is the data. And what is the definition of immediate addressing mode? I need to move the 8-bit or 16-bit data. I need to specify this data in the instruction itself. So here, see, this 05H is the data which we are moving into the accumulator. A stands for accumulator. And this addressing mode is immediate addressing mode. It says you need to have the data in the instruction itself. And one more thing I need to cover here is the number of bytes the instruction is taking. I mean the size of the instruction you need to tell. So whenever we talk about the size of the instruction, let's say I take the example MVI A, 05H. We have put this example for the immediate addressing mode. In actuality, this instruction is MVI A, 8-bit data. 8-bit data. Fine. So this instruction in actuality is this MVI A, 8-bit data, and corresponding to this we have a opcode. Corresponding to this we have a opcode, and through which microprocessor will understand that I need to move 8-bit data into the accumulator. Fine. And now it means, for example, randomly I'm taking this value as, let's say, AC, yeah, AB. Let's say AB is the opcode for this instruction. Now microprocessor will ask for the data now, and you have put the data equal to 05H. It means 05H. So how many bytes you have given? 1 byte for the opcode and second byte for the 1 byte for the data. It means the size of the instruction will be 2 bytes. Remember. And in the direct addressing mode, in this mode, the 16-bit address of the operand is given in the instruction. जो पहले वाली आपकी इंस्ट्रक्शन थी, जो कि इमीडिएट एड्रेसिंग मोड था, वहां पे हम लोगों के पास डाटा गिवन होता है directly in the instruction, but here in the direct addressing mode, we are given with the address. Fine. For example, we use an instruction LDA 2500. So the meaning of this instruction is load accumulator directly with the content, which is placed on the memory location 2500. Let me further explain this. Let's say you have different memory location here. You have different memory location here, and on these locations you have some data. Fine. Let's say this location is 2000, for example. On 2000, let's say data is A, B. For example, A, B is the data. If I'm using here an instruction LDA 2000, so 2000 is the memory location. So 2000 is the address of the memory location. So what we are doing, what this instruction is doing, this is loading the accumulator with the data which is placed on the location 2000. It means A will be loaded with the data AB. Fine. So these kinds of instructions are actually using direct addressing mode. And as far as the number of bytes are concerned, the size of the instruction is concerned. So this instruction is actually LDA 16-bit data. 16-bit data. Fine. And it means this corresponding to this, there will be some opcode. Let's say again I assume C5, for example. C5 is the hex code for this instruction. Now after executing this one, microprocessor will ask for the address, and address we have given is 2000, and 2000 address is taking how much byte? It is taking 2 byte, and C5 is taking, for example, 1 byte. So the size of the instruction will be 3 byte. Remember. And in the register direct addressing mode, the registers are involved. Actually, in the instructions, the registers are there to manipulate the data. For example, the instruction is move C, D. Here, we are moving the content of the D register into C. And remember, the content of the C are overlapped, overwritten, but the content of the D remain same. For example, we have moved the data 05H into C register, and C was having, let's say, 03 first. Now it will become 05H in the C register, but D will also hold the 05. So data of D will not get modified. So this is a case of register direct addressing mode. And as far as the size of the instruction is concerned, this is actually 1 byte instruction, because here microprocessor need not to ask for the data or the memory location, because here we are just copying the content of one of the register into the C, and microprocessor is not interested in knowing the whether what kind of data is present in the C or D. It just copy the content of the D register into the C register. Next one is register in direct addressing mode. In this addressing mode, the register contains the address of the operand. जब मैं register direct बोलता हूँ, तो वहाँ पे directly there is something into the register. But here in this case we have the address in the register. अब की बार मेरे पास यहाँ पे register में address पड़ा है. Fine. So for example, let me take one example. Move A, M. move a comma m. That means move the data of, move the content of the memory location into the accumulator. Fine. So, and the memory location is there in the HL pair. Memory location कहाँ पे होगी? HL pair में. इसका भी एक बार example से हम लोग prove करते हैं how we are taking this. Let's say we have move a comma m. Fine. Obviously, microprocessor is taking this instruction as single instruction and it is putting only 1 byte for that. I mean the size of the hex code to implement this instruction is 1 byte, but here you all know m represents the HL pair. M represents the HL pair, and HL pair always contains some memory location. Let's say 3000 is the memory location which is there in the HL. And on this 3000 memory location, let's say data is 35H. 35H. So this instruction actually move the data 35H into the accumulator. So now you might have understood that in case of this move a comma m, the data is there in the memory location, and that memory location is in the HL pair. Fine, and HL pair is being represented by the m, the memory, m. And normal practice is to represent the memory. Let's say I write here 2000. You may understand that this is your data. But if we represent this in the square bracket, by default, it is our memory, remember. And in the second case, in the last case, we have the implicit addressing mode. In this mode, the operand is always there in the opcode. वहाँ पे मुझे अलग से कोई भी डाटा को मेंशन करने की जरूरत नहीं रहती. जैसे कि हम लोग एग्जांपल पुट कर सकते हैं. फॉर एग्जांपल, मान लीजिए CMA is one of the instruction. CMA, what CMA is doing? It is complementing the content of the accumulator. Here, I need not to write here CMA or any, let's say some data I need not to write here. So the data is itself contained in this opcode. This is actually the opcode and we need not to mention any operand here. So whatever the data you are giving here, for example, AB, it will be complemented. Fine. So this is how we are working. And remember, this is also a 1 byte instruction. Here, microprocessor is nothing to, nothing to implement other than सिर्फ जो है accumulator का जो content है उसको complement करने के अलावा it is nothing to do with that. तो accumulator में जो भी content पड़ा हुआ, let's say AB है, it will be complemented. इसका once complement find हो जाने के बाद the data will again go into the accumulator. So this is the size of this instruction is 1 byte. So this was the first question जो हम लोगों ने पढ़ा कि what is an addressing mode and how many addressing modes are there. 5 आपने देखा अभी 5 हम लोगों ने addressing modes पढ़े और उसका एग्जांपल आप लोगों ने पुट करना है. This is one of the question that can be asked in the PTU exam. Fine. And the third question is, थर्ड क्वेश्चन मैंने आपको दिखाया था अभी, व्हाट इज एन इंस्ट्रक्शन एंड इंस्ट्रक्शन फॉर्मेट, एक्सप्लेन एनी 10 इंस्ट्रक्शन विद एग्जांपल. दोबारा फिर एक बार इसको डिस्कस कर लेते हैं. लेट मी सी द स्क्रीन फर्स्ट. तो फर्स्ट आपसे पूछा कि व्हाट इज एन इंस्ट्रक्शन. So what is an instruction? Any student can answer this question. What is an instruction? An instruction is a command given to the processor to execute an operation. Fine. And one more thing, for example, let's say we mention here move, for example, move C comma A, for example. So what we are doing here, moving the content of the accumulator into C register. So this can be one of the example. And now instruction format. अभी मैंने पहले भी बताया आपको. Now the instruction format. Instruction format is actually composed of two parts: the opcode and the operand. So this is the format of the. It composed of opcode plus operands. और ये हम लोगों ने पहले डिस्कस किया था. So this operands, opcode specify करता है the operation. What operation we need to perform? What operation we need to perform? And this shows the entities on which we need to operate. Hope you are getting. And for example, again मैं फिर से सेम एग्जांपल पुट कर रहा हूं आपके सामने. मूव C comma A. It means operation क्या है? Move. We need to move something. Microprocessor need to move something. And what it should move, it depends on the operand. So entities on which we need to operate, हम लोग किसके ऊपर ऑपरेट कर रहे हैं? We are operating on registers. Accumulator से डाटा हम लोगों ने C में मूव करवाया. These are our operands. So here, in addition to the registers, we can have, I mean obviously रजिस्टर तो इंस्ट्रक्शन में दिए हुए हैं आपको. फर्स्ट वन रजिस्टर हो सकते हैं यहाँ पे. डाटा इटसेल्फ कैन बी प्रेजेंट, जैसे इमीडिएट एड्रेसिंग मोड में होता है. फाइन. एंड थर्ड केस इज द मेमोरी लोकेशन. इट यू मे बी गिवन विद द मेमोरी लोकेशन व्हिच इज देयर इन केस ऑफ डायरेक्ट आई मीन रजिस्टर इनडायरेक्ट एड्रेसिंग मोड. ये तीनों आप एक्चुअली जो इंस्ट्रक्शंस हैं सारी दोज आर I mean interrelated with the addressing mode. So remember, कोई भी instruction आपके सामने आती है, we should know the size of the instruction as well as the addressing mode the instruction is using. So here the entities can be register, it can be a data, or it can be a memory location. Fine. So this is about the instruction format. Now we have different types of instructions. अब आपको पता है कि जो हमारा ALU होता है, ALU performs the arithmetic as well as logical unit. तो मुझे यहीं से पता लग जाता है कि I have the instruction, arithmetic instruction भी रहेंगी मेरे पास. I shall be having the logical instructions also. Fine. So I mean in the paper you may be asked, जैसे अभी जो मैंने आपको क्वेश्चन दिखाया था उसमें सिर्फ 10 इंस्ट्रक्शंस आपसे पूछ रखी हैं. अपनी मर्जी से आपने यू नीड टू एक्सप्लेन 10 इंस्ट्रक्शन. तो वो तो लिए आपके लिए इजी है बिकॉज देयर इज अ सेट ऑफ 74 इंस्ट्रक्शन. आउट ऑफ 74 इट इज वेरी इजी टू रिमेंबर, आई मीन 10 और मोर देन दैट. बट इन द एग्जाम इंस्टेड ऑफ आई मीन राइटिंग 10 ही मे आल्सो गिव यू द लेट्स से explain the following instruction. MVI, for example LDA, for example move. Fine. It can be STA, for example HLT, for example LXI. You can ask you INX, for example, and in the same way you may be asking RLC, for example, RRC, for example, and in the same way exchange, XCHG. So different instruction you may be given, then you need to explain the instruction. Here remember, you will not be given that MVIB, 05 को explain करो. Fine. या फिर LDA 3000 को explain करो. This will not be given. यहाँ से तो आपको डायरेक्ट पता ही लग रहा है कि इंस्ट्रक्शन का एड्रेसिंग मोड भी पता लग रहा है. नंबर ऑफ बाइट्स द इंस्ट्रक्शन इज आल्सो यूजिंग. इट इज आल्सो आई मीन you can also get the knowledge of the addressing mode. So it means you will not be given with these data items or simply the operands. It will give you the instruction itself. Only opcode दे रखे होंगे और आपने खुद ही यूज करना है कहाँ पे एड्रेस है कहाँ पे डाटा है. So let us again discuss very quickly the instructions of instruction set of microprocessor 8085. Fine. So we have the data transfer instruction, arithmetic, logical, branching, and control instructions. In the data transfer instruction, normally we go for the move instruction. तो जैसे मैंने आपको पहले ही बताया था, अभी एग्जांपल भी लिया था आपके सामने, move b, c, we are copying the content of the c register into b. एक बात और याद रखना, जब पेपर में मान लो आपसे पूछ लेता है कि अपनी मर्जी से आपने इंस्ट्रक्शन लिखनी है, तो ऐसे मत लिख देना कि यहाँ पे move b, c, move, सारी मूव की इंस्ट्रक्शन मत लिख देना। यहाँ पे मान लो मैं लिख दूं a, c या a, d। फाइन। तो रिमेंबर, मूव इंस्ट्रक्शन सिर्फ एक ही यूज करेंगे आप, चाहे कोई भी आप यूज कर सकते हैं। फाइन। ओके, मूव b, c and next is move m, d. So move the content of the b register into the memory location specified in the HL pair। जो भी HL pair के ऊपर लेट से मैं कहता हूँ 3000 पड़ा है और उस पे b का डाटा जाके स्टोर हो जाएगा। मूव c, m, और यहाँ पे हम लोग क्या कर रहे हैं, किसी मेमोरी लोकेशन का डाटा जो कि HL पेयर में पड़ी है उसको हम लोगों ने c रजिस्टर में मूव करवाना है। लेट्स से HL पेयर में मैंने डाटा कंसीडर कर लिया 3000, सॉरी लोकेशन कंसीडर कर ली 3000 पे जो डाटा पड़ा है वी हैव मूव्ड इनटू द c रजिस्टर। नाउ MVI m, 05 move immediate the data 05H into the मेमोरी लोकेशन। मेमोरी लोकेशन कहाँ पे होगी, HL पेयर में होगी। HL पेयर 3000 है तो 3000 के ऊपर जाके आपका डाटा स्टोर हो जाएगा इनटू दी मेमोरी लोकेशन 3000। LDA 3000, दिस इज आल्सो गुड इंस्ट्रक्शन एंड मोस्टली इट इज कम्स इन द एग्जाम। फाइन। जब भी कोई इंस्ट्रक्शन आएगी पेपर में तो मान लेना कि LDA तो आपका जरूर रहेगा वहां पे। सो लोड एक्यूम, मैंने अभी बताया भी था आपको, लोड एक्यूमुलेटर डायरेक्टली विद द कंटेंट ऑफ द मेमोरी लोकेशन 3000। तो 3000 के ऊपर जो भी डाटा पड़ा होगा वो एक्यूमुलेटर में जाके स्टोर हो जाएगा। नेक्स्ट वन इज अगेन वेरी इंपॉर्टेंट इंस्ट्रक्शन LXI। हम लोगों ने वी हैव यूज्ड दिस इंस्ट्रक्शन while working with this UA lab. So LXI register pair 16-bit data. RP stands for register pair. Load immediate the register pair with 16-bit data. तो यहाँ पे मेरे पास मैंने एग्जांपल पुट कर रखा है LXI B, 3202। Let's say always remember ये I need not to tell again and again that let's say I'm talking about only 45. So this is our 8-bit data, but when we are writing here 45 4535, it will be a 16-bit data. So here remember the upper byte always goes to the, and when before telling this let me represent here, we are written a RP, so I need not to write here BC, because you know the valid combinations are B will make combination with C, D with E and H with L, but we need not to write here BC, because if you are writing here B by default, it says you are considering the BC pair. And remember, the higher byte of the data will go to the B register and lower byte will go to the C register. Remember, so BC will be loaded with the content 3202 here. Next one is LHLD. This is also important instruction, LHLD. 16-bit address, LHLD 16-bit address. That means load HL pair with 16-bit address. तो यहाँ पे आपने देखा होगा कि हम लोगों के पास मेमोरी लोकेशन जो यूज करते हैं वो HL पेयर को यूज करते हैं, लेकिन यहाँ पे इंटेंशनली आप HL पेयर में कोई जो मेमोरी एड्रेस है वो लोड करवा रहे हैं, तो उससे आपको कैसे काम कर रहा है लेट अस सी। तो यहाँ पे क्या चीज है मेरे पास, दिस इंस्ट्रक्शन विल लोड द डाटा फ्रॉम 3000 एंड 3001 टू दी HL पेयर। तो आप देख पा रहे होंगे यहाँ पे जब हम लोग इसको एज ए मेमोरी लोकेशन यूज करवा रहे हैं तो तब तक तो ठीक था, लेकिन इस इंस्ट्रक्शन के अंदर वी आर लोडिंग दी HL पेयर विद द डाटा व्हिच इज देयर ऑन द 16-bit एड्रेस। तो यहाँ पे आप देख पा रहे होंगे हम लोगों ने एग्जांपल कंसीडर किया LHLD 3000। तो 3000 के पास जो लोकेशन के पास जो डाटा रहेगा वो L में चला जाएगा, एंड जो 3000 नेक्स्ट वाली इंस्ट्रक्शन आएगी, आई मीन जो नेक्स्ट वाला एड्रेस रहेगा 3001, दैट डाटा विल मूव टू दी H। रिमेंबर, जो आपके पास फर्स्ट बाइट होगा वो हमेशा मूव करेगा लोअर रजिस्टर में, आई मीन L में, और जो अपर बाइट होगा आई मीन दी सेकंड मेमोरी लोकेशन रहेगी जो सेकंड टाइम पे आएगा दैट विल बी गो इनटू दी H। सो रिमेंबर, कंटेंट ऑफ द 3000 that means 25 copied to L and 3001 get copied to the H. This is also one of the very important instructions, LHLD 16-bit address. Now STA 16-bit address. We have used this instruction a number of times. That means store the content of the accumulator to the 16-bit address. ये हम लोगों ने कई बार यूज किया है. तो यहाँ पे एग्जांपल पुट कर रहे हैं STA 2525. That means let's say after execution of an instruction, you know the result always gets stored into the accumulator. So if I want to store this result of the accumulator to some particular memory location, then I'm going to use the STA 16-bit address. Let's say I want to store my data of accumulator to the memory location 2525. Let's say we will be using the STA 25. So 08 data will be moving to the location 2525. That means 08 is there. Exchange, XCHG. So remember this, exchange the HL pair with the DE. जो exchange होता है मेरे पास, this instruction always exchange the HL pair data with the DE. जो ये बात यहाँ पे याद रखने की क्या है, जो H वाला डाटा होगा that will be exchange with the D. I mean upper register वाला जो है वो upper के साथ, lower वाला lower के साथ. L का डाटा जो होगा that will be exchange with the E. तो यहाँ पे आपके सामने मैंने example भी put कर रखा है. Here exchange is also comes in the category of implicit addressing mode. It comes in the category of implicit addressing mode. Fine. And here you can see D and E data was 2525 and in the HL pair it was 20 and 2000. So it means those data get exchanged with each other. And after execution of this instruction, the data is also shown here. H and L will get 2525 and D and E will get 20 and 00 respectively. Next instruction is SPHL. Copy the content of HL pair to the stack pointer. आप देख पा रहे होंगे यहाँ पे SPHL. आप यहाँ पे देख के ऐसे समझ सकते हैं इसको, मुझे HL को SP में मूव करवाना है. जो भी HL का डाटा है मेमोरी लोकेशन रहेगी उसको मैंने स्टैक पॉइंटर के ऊपर डालना है, बस नथिंग एल्स. एंड PCHL में क्या करते हैं, प्रोग्राम काउंटर पहले हमने SP में डाला था, अब की बार प्रोग्राम काउंटर में डालना है, बस नथिंग एल्स. HL का डाटा, HL की जो लोकेशन है दैट वी आर पुटिंग टू दी program counter. So let's say HL में 2500 था, तो PCB after execution of this PCHL it will also move to the 2500. Fine. So again we need not to mention here any address of the data. So the addressing mode will be implicit addressing mode in both of the instruction, and the size of the instruction is obviously 1 byte. Now the arithmetic instruction में आपके पास we have before that R/M. We write here add R/M. We are adding the content of the register /memory with the content of the accumulator. And remember, after addition, some flags get affected, and immediate flag that get affected is the carry flag. Add M in the same way. We are adding the content of the memory location. Memory location में आपके पास HL pair में जो रहेगी उसके ऊपर जो डाटा रहेगा, let's say A2 है, और A2 is get added with the 76. Fine. ADI, I mean जो instruction हम लोगों ने पढ़ी थी immediate addressing के लिए, MVI की जगह यहाँ पे we have the ADI. So ADI is add immediate 8-bit data. It means यदि instruction में आपके पास data itself present है, तो उस वाले इंस्ट्रक्शन को हम लोग वहां पे बोलेंगे कि वी आर यूजिंग दी इमीडिएट एड्रेसिंग मोड. फाइन. और ऑब्वियसली 2 बिट की जो 2 बाइट की आपके पास इंस्ट्रक्शन जाएगी. सो एडीआई 8-bit डाटा, मूव द 8-bit डाटा इनटू add immediate the 8-bit data into the data of accumulator. Now this is again one of the important instruction. Remember DAD-RP. DAD-RP means RP stands for register pair. So here what this instruction is doing, it is adding the 16-bit content of the register pair to the content of the HL pair. हमेशा याद रखना, अभी तक हम लोग जितनी इंस्ट्रक्शंस पढ़ी हैं, हम लोग कहते हैं कि एडिशन होने के बाद, ऑपरेशन परफॉर्म होने के बाद the data gets stored into the accumulator. But here in this case, we are adding the content of the register with the content of the HL pair. Remember. So here, let's say register pair we are mentioning here is B. मैंने आपको पहले ही बताया था, we need not to write here BC. We just write here B. So we are considering that the content of the BC will be added with the content of the HL. So HL is 2525, BC is 3232. So ultimately we are left with the content of the this 5757. And remember, this content gets stored in the this get stored into the HL pair again. BAD is also important instruction. Then subtraction operation, again same. SUB R oblique M, subtract the content of the register oblique memory from the content of the accumulator. SBB R oblique M, subtract with borrow. Subtract with borrow the content of the register oblique memory from the content of the accumulator. फाइन, इसका दोनों में डिफरेंस क्या होगा? हम लोग क्या कर रहे थे पहले, एस बी बी मान लीजिए मैंने यहाँ पे पुट कर लिया, तो यहाँ पे एक्यूमुलेटर में 08H है, बी में 03H है, कैरी फ्लैग में 1 है. तो यहाँ पे पहले वाले इंस्ट्रक्शन में वी डू नॉट टेक इनटू अकाउंट द कैरी फ्लैग, बट हियर इन दिस केस आफ्टर एग्जीक्यूशन 0 08 minus 0305, and we are also subtracting the content of the carry flag. Fine. And why we are writing here carry flag? Because the carry in the addition as well as the subtraction, the borrow in the subtraction, both are having the same sense in the computer system. So here the carry flag is also taken into account. So data at the output will be 08 minus 0305, 05 minus 1 is 4. So at the in the accumulator at the end we have the 04. SUI 8-bit data. This is again the instruction which is using the immediate addressing mode. It says immediately subtract the content of the 8-bit data from the accumulator. Fine. SBI subtract with borrow. Borrow भी consider करेंगे यहाँ पे. Next one INR R oblique M. Increment the content of register oblique memory. INR हम लोग यूज करते हैं सिंगल पेयर के लिए, सिंगल रजिस्टर के लिए. मान लीजिए मेरे यहाँ पे एग्जांपल है INR B. So it is increment the content of the B register. Let's say increment आपके पास जो register में content था that was 05H, and we have moved this content. We have incremented this content by 1 bit. It means the register content will now become 06. So INR is also one of the instruction. INR M, it means HL pair का content आप increment कर देंगे. DCR अब की बार decrement के हैं, जैसे INR और हम लोगों ने INR R और M पढ़ा था. इन द सेम वे वी हैव द DCR R oblique M. यहाँ पे एक बिट सिर्फ डिक्रीमेंट हो जाएगा. फॉर एग्जांपल DCR B यूज कर रहा हूँ, B will be decremented by 1. Now the logical instruction we have the ANA R oblique M to AND logical AND operation of the register R with accumulator. For example ANA B. ANA B में हम लोग क्या करेंगे, B में जो डाटा पड़ा रहेगा उसको हम लोग एंड ऑपरेशन परफॉर्म करेंगे एक्यूमुलेटर के साथ. एक्यूमुलेटर में फॉर एग्जांपल द डाटा वाज 05H और B में मेरे पास 06H है. इसको बाइनरी फॉर्म में लिख लेते हैं और एंड ऑपरेशन परफॉर्म करेंगे. एंड में क्या होता है, जब भी 1 रहेगा तब आउटपुट आएगी, बाकी के केस में आउटपुट विल बी 0. सो दिस इज हाउ वी आर गेटिंग द आंसर 04H into the accumulator after performing the ANA B. Now in the same way we have the ANI 8-bit data. यहाँ पे डिफरेंस क्या रहेगा, इंस्टेड ऑफ द डाटा ऑफ द रजिस्टर वी आर डायरेक्टली 8-bit डाटा को हम लोग एंड ऑपरेशन करवा रहे हैं विद द कंटेंट ऑफ द एक्यूमुलेटर. नेक्स्ट इज द ORA R oblique M. ORA stands for logical OR operation. Perform the logical OR operation of R oblique M content with the content of the accumulator. R की वैल्यू यहाँ पे B हो सकती है. लेट्स से B रजिस्टर इज देयर, B में आपके पास कंटेंट 06 है, एक्यूमुलेटर में 05 है. सो वी आर परफॉर्मिंग द लॉजिकल ओर. सो लॉजिकल ओर में क्या होगा, एक भी इनपुट हाई हो जाती है तो आउटपुट हाई हो जाएगी. सो इट विल बी 1, 01 is 1, 11 is 1, 11 is 1, 00 is 0, and every time whenever you have all zeros the output will be 0. ORAM ऐसे हम लोग HL पेयर के साथ कर लेंगे. ORI 8-bit डाटा, और ऑपरेशन हम लोगों ने करना है 8-bit डाटा के साथ. Next one is the XRA R oblique M. We are performing the XR operation with register oblique memory. I mean, for example, we have XRA B. So A is equal to 05H. The content of the accumulator is 05H and the register content are 06H. So we are performing the logical XOR operation. You know, in case of XOR operation, whenever the different inputs are there, the output will be 1, otherwise output will be 0. So here you can see 1, 0, 1, 0 is the different input, we are getting output 1, 0, 1 के लिए आपके पास 1 आ रहा है, same input के लिए always you are getting 0. ऐसा मैं क्यों बोल रहा हूँ? Because we have already studied in our display electronics we have already studied in our DE. The expression for the XOR is, XOR के लिए ऑपरेशन क्या होता है? Y is equal to AB bar plus A bar B. So if you draw this, this is A, this is B, this is Y. So 0, 0, 0, 1, for example, 1, 0, and 1, 1. So output here will be, if you are putting here, for example, 0, B will become 1, then plus, again A is becoming 1 and B is 0. So basically you can see both are 0. Fine. At the same time, if I am putting here 1, 1, 1, 1 के लिए भी दोनों आपका 0 हो जाएगा. But if I am putting the different value, for example, A is equal to 0, B is 1, it is also 0. Plus A was 0, it will become 1 and B is same. So it is 1, 1, 1. So this is how, that's why I am saying this, the XOR operation is like this. XRI अब की बार 8-bit डाटा के साथ XOR ऑपरेशन कर देना है. नेक्स्ट इज द कॉम्प्लीमेंट हम लोगों ने पढ़ लिया. कॉम्प्लीमेंट में क्या करेगा? सिर्फ वंस कॉम्प्लीमेंट करेगा. कंटेंट ऑफ द एक्यूमुलेटर आर फॉर एग्जांपल 06, so it will be 0 represented by 0 0 0 0 0 1 1 0. It means 0 get converted into 1, 1 into 0, 1 into 0, 0 into 1, and ultimately the answer will be this 1 1 1 1 in hexadecimal, which represent the F, that means 15. And 1 0 0 1, this is 9, so it will be F9. F9 is the right answer after performing the CMA operation. Next is the CMC, complement the carry. Whatever the carry flag was there, it gets set equal to 1. Sorry, it gets complemented by 1. If it was 0, it will become 1. If it was 1, it will become 0. And set carry. This sorry, in set carry, whatever the carry was present, it will get set. It means the value of carry flag will become 1. And in the same category, we have the rotate instruction. Rotate accumulator left. RLC is for rotate accumulator left. Fine. इसको कैसे rotate करेंगे? Let's say data is 05H into the accumulator. We are moving the data toward left side. You can see from here, we have the data from D node, D1, D2, D3, D4, D5, D6, D7. So D7 data will rotate, toward left side. If this comes out, it goes to the carry flag, and it also occupies, you can say if this D7 is coming out, then D6 is taking the position of D7, D5 is taking the position of D6, and ultimately D node is taking the position of D1. So it gets emptied, and this is filled by the last digit, that means D7. So this is a case of RLC instruction. Then rotate accumulator right. जब right move करेंगे तो क्या होगा? जो D node है आपकी बात, that will fill the carry flag. Then D1 will become D node, D2 will become D1, and ultimately D7 become D6. So this empty cell is filled by the D node. In that case, in case of RLC, it was filled with the D7, but here we are filling this with the D node. So this is the case of RRC. So you need to tell the the content of this register after execution of the instruction. So let's say it was 1 0 0 0 8 0 0 1 1 3. It was 83H. Now it is becoming 1 1 0 0. That means C, and 0 0 0 1. That means 1. So answer will be C1. RAL, rotate accumulator left through carry. पहले हम लोगों ने without carry move करवा रहे थे, but this time we are moving through carry. RAL and RAR both are the instructions. So here you can see we are moving the D7 into D1, and then in the RLC we were moving it backward to fill the D node. But here you can see we have shifted this D7 into carry flag, D6 into D7, D5 into D6, but this D node which get emptied, this cell is filled by the carry flag. Instead of D7, the carry flag is also taking part in the rotation. And same is there in the RAR instruction. In the RAR instruction, we are moving rightward. D node fill the carry flag. D1 become D node, D2 become D1, and ultimately D7 become D6. So this empty cell is filled instead of D node. That was the case for RRC. We are filling this by the carry flag. Whatever the data was present in the carry flag, it gets shifted into the D7. So this is the case of RAR. In the same way, we have the compare instruction. We have used this instruction by working with the COA lab while we were, comparing two number. We were finding which one is a larger number among two number, and one experiment was also there in which we need to find the largest number among the array of number. उस केस में हम लोगों ने 10 नंबर कंसीडर किए थे और CMP इंस्ट्रक्शन यूज किया था. CMP instruction is actually performing the subtraction operation, and it is finding that which number is greater, which is less, and if they are equal, these three conditions are actually shown by the CMP instruction. So these are three instructions. So let me use here CMPB. So compare the content of the B register with the content of the accumulator. तो यहाँ पे accumulator का content आप देख पा रहे होंगे 90 है. जो B का content है that is CD. तो हम यहाँ पे क्या करते हैं, सब्ट्रैक्शन परफॉर्म करें. 90 हमेशा जो सब्ट्रैक्शन रहेगी दैट विल बी A माइनस B, A माइनस मेमोरी लोकेशन. सो याद रखना इट इज 90 माइनस CD. तो 0 में से D नहीं जा सकेगा, तो आई नीड टू टेक द बोरो हियर. 16 माइनस B इज 3 एंड हियर इट इज बिकमिंग 8 प्लस फिर से बोरो लेने पड़ेगा बिकॉज 8 में से C नहीं जा सकता. सो 16 प्लस 8 इज 24 में से 12 गए, दिस इज C3. सो दिस इज अवर C3. रिमेंबर हियर we also need to find the value of the status flag because we are subtracting the larger number from the smaller number. The answer will be negative. That's why the sign flag is 1, and because answer is non-zero, zero flag is 0. X की वैल्यू जो हम लोग unused जो बीट है उसको 0 पुट कर देते हैं and parity flag चेक करते हैं. The answer in the answer we have the even number of 1, so the parity flag is 1. X is again put here 0. Carry flag, because we have taken the borrow, so carry flag will also be 1. But rest of the last one is auxiliary carry. Auxiliary carry में याद रखना हमेशा auxiliary carry तब 1 होगा जब lower nibble of the accumulator is greater than result. Lower nibble of the accumulator, that means lower nibble मतलब ये वाला पार्ट, ठीक है, lower part. So this is 0 और किससे, result से. result में है 3. because this 0 is less than 3, that means जो auxiliary जो carry है that will be 0. And otherwise, for example, this was 95 and this is 3, then the value of auxiliary carry will be equal to 1. Remember. So in the same way, we can compare with the CMP, then CMPM, then we can compare CPI. यहाँ पे 8-bit data की form में given होगा inside of register and memory. So next is the jump instruction, JMP 16-bit address. Here we are transferring the control of the microprocessor to the 16-bit address. So here we are jumping unconditionally. We are given with some address, let's say JMP 2050. So microprocessor is moving to the 2050 location, but this jump instruction can be conditional. And you might have seen in your while working with the experiments on COA lab, we have used the JNC or JC, jump if not carry. So that kind of conditions are actually, those are actually like JC, jump if carry, jump if not carry, jump if the number is positive, negative, jump if it is 0, jump if it is not 0, jump if the parity bit are even, if the jump if the parity is odd. So this is how we are jumping in our program. So call instruction, call unconditional. If we are, putting some address, so this is unconditional jump. जैसे मैंने GMP के केस में था ऐसे ही कॉल के बारे में, but here we are directly moving, we are not putting any condition, fine, and here we are putting some condition. In the same way, call 16-bit address, we are giving some address where the subroutine is calling the microprocessor. So this is the unconditional jump. For example, call 2050. But if the conditional jumps are there, we need to put some condition. Let's say CC, call if carry, call if not carry, call if the number is positive, call if the result is minus, the call if it is 0, the result is 0. And remember, the in addition to, in synchronism with the call instruction, we need to use the return instruction also. So at the same time, that's why I'm showing you the both call if carry, call return if carry, return if not carry, return if positive, return if negative, return if 0, return if not 0, return if the parity is even, return if the parity is odd. So this is all about the answer of your two questions. So I hope I have given you the answer of these two questions. And you can comfortably attempt now these two questions if they comes in the P2 exam. Fine. That's all from my side for today. Let me take your attendance. If you have any query, you can ask me. So these are present students: 72, 73, 74, 75, 76, 77, 78, 79, 81, 82, 83, 86, 84, 85, 86, 88, 89, 91, 93, 94, 95, 96, 97, 98, 100, 102, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 32, 33, 34, 38, 39, 40, 41, 43, 44, 45, 46, 49, 50, 51, 52, 53, 54, 57, 58, 59, 60, and 61. So this is the list of present students. So that's all from my side for today. I'll see you in your next class. Till then, goodbye.